Okay, I have an example now, and gotta be careful about it. There's numbers are being thrown around here. There's a 10,000 acre forest, and it's able to support 1,000 deer. They go on to say that's the carrying capacity, right? That's what A is. It says also assume the population follows a logistic model. So this model over here, where K is going to be this number over here. Find the deer population if the initial beginning population of the deer is 100. So let's take a look at, and certainly I want to go to the whiteboard again because I don't have room to put it here. And as I do that, you would need access to this written document to know what I'm reading at this point, all right? So we're reading this, and we're going to try to figure out what to do. By the way, I need to know this as well. So what I do is go to the whiteboard, and let me write down what I have been told, all right? So a couple of things I've been told. I've been told that the carrying capacity is 1,000. All right? That's one thing I've been told, by the way. By the way, the 10,000 acre forest really, not 10,000 acres, just simply said this forest is able to support 1,000 deer. That's a carrying capacity, all right? It says also assume that the population follows a logistic model, right? So I know the logistic model, and I got that written over there. It says where K is equal to, let's write that down. What's K equal to? 0.4. Okay? Then it says find the deer population if the initial population means T equals 0. So I'm going to write this over here. So Y at 0, where they tell me, is 100. So I'm going to write this down. I'll see what the question is in a moment. What's A? A is 1,000. And what do you get here? You get 1 minus, well, let's be careful about this. I mean, I have to write down what I'm getting over here. So it's going to be, e to the minus K, which is 0.4. Well, T is going to be 0. That makes it a lot easier for me. Then I'll put the C star over here. All right? Let me see if I can figure this out. I'm looking at it. It doesn't look like bad an equation. I'm going to maybe simplify a little bit, and I'll say 100 here. I'll say 1,000 here. This is 1 minus, e to the, minus 0.4 times 0 is just e to the 0, which is 1. So 1 over C star. Well, simple algebra. I'll put this over here. 1 minus 1 over C star. That's going to be equal to 10. And then I'm going to say minus 1 over C star is equal to, I'm going to subtract 1 from both sides, 9. So I'm going to say C star is going to be equal to minus 1/9. All right, let me see if that makes sense here. So I got the initial population, carrying capacity. Yeah, I think I'm doing okay. So what I want to do is move forward, and I got that C star business, and let's write this down now. So Y as a function of time is equal to 1,000. And then again, what are we writing down? We're writing down this over here. That's all we're doing. What's going to be 1 minus E, what's going to be minus 0.4, T, and we're dividing by minus 1/9. And so the C star is minus 1/9. So it's going to be plus 9 now. All right? So I got my function. Then it says, how long will it take the population to reach 500? So the question is like, at what time T, this is how long is it going to take? I have no idea. Will it take to reach 500? I don't know. Let's write this down. 1,000, 1 plus 9, E to the minus 0.4 T. Well, what do you get here? I'm going to say it's 1 plus 9 e to the minus 0.4 t is equal to 2. All right, now how do I do that? Divide both sides by 500, multiply both sides by that LCD, which is 1 plus 9 e to the minus 0.4. So let's write this down. So it's going to be 9e to minus 0.4t is equal to, well, let's see, that would be 1, right? Let's keep moving. And what do you get here? You get e to the minus 0.4t is equal to 1/9. Well, I'm going to take the log of both sides, and what do you get? Minus 0.4t equals the log of 1/9. All right, that looks a little strange to me. All right, minus 0.4t. This actually equals minus the log of 9. Well, I think I know what t is right now. What's t going to be? It's going to be the natural log of 9 divided by 0.4. All right? Now, I don't have access to a calculator now, but I'm going to say if I were to use a calculator, and I would say t is approximately, again, I calculate this over here. I'm not doing that in my head, by the way, is approximately 5.5 years. Yes, I did the computation prior. You may want to check that and see if that's true. Thank you.